Namaste. This is JD and Dr. Vishal Saxena, Professor in Mathematics in Department of Science and Technology, Faculty of Education Methodology, JAYOTI VIDYAPEETH Women's University, Jaipur. So today I'm going to take a lecture on the module uh, Basic Operations of SAT. This module is a part of the course Mathematics Second and under the program of uh, DET, DET second semester. So the today's lecture is about the basic operations in set theory, and today we are going to discuss about the various operations. And in the previous lecture, we have discussed about the basic definitions and how many different types of sets are exist and what are the basic definitions. So today we are going to discuss about their operations, and this is a very important module for the students because we will see what are the just the basic operations, basic algebra of set theory. So today just we are going to discuss with some slides, and now we share these slides. So just we can observe that just operations on sets are given there. So just we are going to discuss all these operations. This is a very important lecture for the students because in the set theory means it is a part of the mathematics, pure mathematics, where we discuss about the further about the functions and the mappings and in these just operations, just we will see the concept of operations on the sets. We will use the different concepts of sets. So the first operation on set theory is a union of sets. The union means just combine. Suppose just union of sets is means it is written by union U, and it is given by it is defined as A union B is equal to, it is a set of all those x such that x belongs to A or x belongs to B. So A union B means that is showing the union of sets, union of two sets, A and B, and where it is a set. Set means it is a collection of the element x, and element x means it can lie in the set A. So x belongs to A or the x belongs to set B. So for example, just now we take one example to explain this. Suppose here we are having two sets A and B. One of the set A is equal to, it is 0, 2, 4, 6, 8. The element in the set A are 0, 2, 4, 6, 8. And the set B is given by 6, 8, 10 and 12. 6, 8, 10 and 12. Then the union A union B is given by, just we have to add all the elements. We have to take all the elements, those which in lie in either of the set A or the set B. So it means when we take here A union B, so all the elements of A and B will come there. So 0, 2, then 4, 6, after 6, 8, and then 10 and 12. So just A union B means it is a set, it is a collection of all those elements of set A and set B. Okay, so this is called a union of sets. Next, just we are taking the next operation on sets, and this is called intersection of sets. So intersection of sets means we have to see in this operation the common part, the common element which lie in the two sets, and that is called intersection of two sets. So it is a set of all those elements which just are in both sets A and B. So an intersection is the collection of all the elements that are just common to all the sets under consideration, and it is written by like inverse of u, a intersection b, that is written by A, and it is the intersection, it is the inverse of U symbol, and B, and that is equal to, it is a set, it is a collection of those X, such that X belongs to A and X belongs to B. So this is the definition of intersection of two sets. Means it is a set of all those elements X, which are just lying in both sets A and B. So just we take the one example to explain this. Suppose set A is given by 2, 4, 6, and 8. So the elements of set A are 2 and 4, 6 and 8. So this is the set A, and the set B is given by 6, comma 8, comma 10, comma 12. So there are again four elements in the set B, and now we have to find the intersection of A and B, the intersection of two sets A and B, and this is given by A intersection B. And in this example, just we can observe that only the two elements 6 and 8 are common there. So it means the elements 6 and 8 are common in these two sets, and therefore A intersection B is equal to set consisting 6 and 8. So just the intersection of A and B is given by 6 comma 8 set. Now difference of the sets. This is the third operation, difference of two sets. Difference means we have to just subtract one set from the another set. Suppose we have the two sets A and B, then the difference of two sets A and B is written by A minus B or B minus A. So difference means A minus B or B minus A. But presently now we are discussing on the A minus B. So how we can define it? A minus B means it is called the difference of two sets A and B, and here B is subtracted from A. So this is defined as the set X, the set of those X. It is a collection of those elements X which are lying in the set A but not in the set B. So A minus B means this is a collection, this is a set of those elements X which are lying in the set A but not in the set B. That is called difference of two sets A and B. And if we have to just find B minus A, then in this part here, again B minus A means the difference of two sets and A is subtracted from B. So it is equal to the set of X where X belongs to B, but X does not belong to set A. So it is the set of those X where X are lying in the set B, but the set but the X does not lie in the set A. So let A is equal to this set is given by 1, 2, 3, 4, 5, 6. The set A is 1, 2, 3, 4, 5, 6, and set B is 2, comma 4, comma 6, comma 8. So set B is 2, 4, 6, 8. Then A minus B is equal to, we have to see the elements in the set A but not lying in the set B. So we can observe that in the set B, 2, 4, 6, 8 are coming. So 2, 4, 6, 8, just these elements are not to be taken in the set A minus B, and therefore A minus B is given by 1. 1 is in the set A but not in B. It is 3. 3 is in the set A but not in the set B, and 5. 5 in the set A but not in the set B. Therefore, A minus B is equal to 1, 3, and 5. It is a set of 1, 3, 5. While the B minus A, when we discuss about B minus A, then B minus A is given by the set of those elements of B which are not in A. So when we observe that in the set B, 2 is a common element, 4 is a common element, 6 is the common element, only 8. 8 is in the set B but does not lie in the set A. So B minus A is given by, simply B minus A is given by only 8. It is a set of only element 8. Next is complement of sets. Complement of set is quite similar to the difference of two sets, but complement of set means it is we will subtract the set A from the universal set. So just it is a universal. It is written by A dash. The complement of set is written by A dash, and it is defined as U minus A. So just complement means A dash is given by universal set U minus set A, and this is the complement of sets. So that is now we take just example to explain this here. Now we are taking the Venn diagram to explain these concepts more. In the first diagram, we can see the blue portion is given that, and the blue color is given that for the set A. So it is just showing the set A there. Then just in the next diagram, next Venn diagram, we can observe that the two like sets A and B are given. Universal set U is given. Universal set means it is a set consisting all the sets under consideration. So now we have to find A dash. A dash means it is defined as the complement of A, and it is the universal set U minus set A. So U minus A means that is the A dash, and it is just shown in the second figure by the blue color. So blue color portion, blue color region is showing here A dash, and that means it is the complement of two sets, complement of set A. Now next one is here. A and B are disjoint sets. A and B are disjoint set means here the two sets A and B are just in these two sets there is nothing common. So no element is common in the two sets, and therefore A and B are the disjoint sets. So according to definition of disjoint sets, no element should be common. And this diagram number 3 is showing this. Now next diagram number fourth diagram where a set A is given that and set B is entirely lie inside the set A, and the universal set U is given that. So what it shows here, the blue region in the fourth diagram is the set B, and it is showing shows here the blue portion, the blue region in this fourth diagram is showing the proper subset. B is the proper subset of set A. Next one is the intersection operation. A intersection B means here the common part of the two sets, those elements which are common in means just present in both sets A and B is called here A intersection B. So in this fifth diagram, A intersection B is given that and two sets A and B are there. Universal set is there, and just the blue portion is showing here the A intersection B part. The next and the last Venn diagram is showing that here just a union operation. Union operation means A union B. A union B means it is a set consisting all the elements of A and all the elements of B. So we have discussed already this in the mathematical definition. So A union B is shown here with the blue color, the blue region, and it is a set of all those X where X lie in the set A and the set or in the set B. Means A union B shown here, it is a collection of all those elements of set A and set B also. So next we are going to take some example to explain these topics clearly. So just these operations. Let the set A is given by 1, comma 3, comma 5, comma 7, 1, 3, 5, 7, and set B is 5, 7, 9, 11. 5, 7, 9, 11 is a set B, and set A is 1, 3, 5, 7. So C is just one more set. C is given that 1, 3, 5, 7, comma 9, 11, and 13. So in this way, the three sets are given that, and we have to prove this one identity, one result there. That one is A intersection B, union of A intersection C. A intersection B, union of A intersection C, and this equal to A intersection B union C. So for this, we have to find, we have to calculate both sides, left hand side and right hand side separately, and just we have to see this one. In the left hand side, we can, in the right hand side, we can see this one B union C. So B union C is given that just B union C means we have to add the elements of B and C both, and it is given by B union C. Next one is here A intersection B union C. So just A intersection B union C means in the B union C elements, in the set of B union C, we can see this one 3, 5, 7, 9, 11, and 13. So this is the set B union C, and set A is there 1, comma 3, 5, and 7. So just we can see what are the common elements in the set A and the set B union C. So just common elements are given that here are coming there 1, 3, 5, and 7. 1, 3, 5, and 7 both are the common element. Both these are the elements common in the set A and set B union C. So this is the just A intersection B union C, and this is the part of right hand side. Now next we have to find the left hand side, and therefore we are taking the A intersection B, means the common elements of set A and B. Common elements of set A and B, just see the two sets A and B, and we can observe that 5 and 7 are the two elements, those which are in common in A and B. Next one is A intersection C. A intersection C means the common element A and C are be here in the set A 1, 3, 5, 7, in the set C 1, 3, 5, 7, 9, 11, and 13. So it means the two set in the two sets A and C. What is A intersection C? The A intersection C means the common element are A and C are 1, 3, 5, and 7. So this is the set A intersection C. And now here just we will see what is A intersection B union A intersection C. So now we have to take union of these two sets, just which we have calculated, means a union of A intersection B and union of A intersection C. So this just coming here 1357. So 1357 is the set of A intersection B uh, union A intersection C. And since we can see that the two sides are just same, therefore this identity is proved here. Now one more example we are discussing here to explain this concept more. Let AX set be A, B, C, D, E. Suppose we are having the set X equal to A, B, C, D, E, and set Y is equal to A, E, I, O, U. This is the set Y, and universal set U is given that A comma B C D E F G H I J K L and O U. So now first we have to find these four results, X union Y. X union Y means again we have to find the union of two sets of X and Y, and we have already discussed that it is a union of, means it is a collection of all those elements of X and Y. So X union Y is coming there as A comma B comma C comma D comma E. This is the set X, and the set Y is also there. Just common elements are taken one time. The next elements are here. It is IOU. So ultimately X union Y is equal to A, B, C, D, E, IOU. That is X union Y. And X intersection Y means common part in the two sets X and Y. And we can see that only D and E, only D, not D and E, only A and E are the two elements. Just these are the common in the two sets A and E. Next, third result is X dash. X dash is given by the complement of set X, and complement of set X means we have to find U minus X, universal set minus X, and it means we have to subtract x from the universal set U, and therefore A, B, C, D, E lying in set X will not come in this X dash. So what will come there? Just excluding A, B, C, D, E in U, that is F, G, H, I, J, K, L, O, U. So this is the set X dash, and then X minus Y. In the same way, we can subtract the set Y from X, and this is called X minus Y. This means it is a difference of two sets, X and Y, and this is coming there B, C, D. It is coming here BCD, and this is the example of like operations of two sets. So in the today's lecture, we have discussed about the set operations, and this is a very important part of mathematics. And students of DET in CS, diploma students in computer science, are supposed to practice for these definitions, these concepts of operations of sets. And with this, I'm just I'm concluding my today's lecture. Thank you.